Welcome to stream number 2 of the triple TMC5130 motion controller build. In this stream, we are going to finalize or try to finalize component selection, and we are also going to try to route the PCB. First thing that we need to do is see if we can find some new components to free up some space. At the end of the last stream, we saw that we could need a bit more space. If you have any questions, just fire them off in the YouTube chat or in the Twitch chat. If there are any issues, just let me know. Okay, let's fire up the EASYEDA window. Okay, so this is another TMC5130 driver, which called Macadunio. That's a special board made to sit behind a TMC5130. This is actually not a bad device. If it works, it probably works. So if you want to get something like this, you can probably search for Macadunio Alt or use this search that I made. It's called circuitsearch-human.marisair.com. I can share that to the chat, actually. Let's try to do that. I'll share it in both chats. Okay, not sure how to do that in the YouTube chat. Okay, whatever. Yeah, but you can see the link through the video. Okay. So let's bring up our design. Okay. Let's log in. I'm logging in off screen. And let me bring in, there it is. Okay, so let's bring out the circuit board. Oh, I forgot to lower the sound on my cell phone. There. So as we see, something that takes up a bit or a lot of space is the two large capacitors and the sense resistors. Obviously, the sense resistors can be made a lot smaller. I also said that we were going to recreate the outline for the board, and we are actually going to do that as well. However, we are going to try to make that as, let's see, first we'll just make it as a new project, actually. We could make it a new schematic module. Okay, we can try. Let's try to save this. And then we'll call it modular CNC 6060 base or template. Okay, let's change from mil to inch, and let's add snap size of 1 millimeter alternative 0.5, and a grid size of 1. I actually mean 10. 10. Okay, let's create an outline. So this board will be 60 times 60, at least for starters. Okay, so I made it minus 30, oops, 30, minus 30, and axis, and y is 30. Okay, now it looks weird. I must have forgot. Okay, let's just pull it down like this. There. However, this looks weird. Why is it not centered? Okay, we'll do it a bit different. We'll just do line after line. Minus 30 plus 30. There. And then we'll just copy this top line and add it 1, 2, 3, 4, 5, 6. And then add this one here. So that's a perfect square. Now we are going to add the holes. So in order to do that, I'm actually going to make a square. And yeah, I might explain that later. So the outer diameter should be 10. And the hole should be 4.5. And I actually noticed now that I did something wrong. I need to change the snap to 5mm because it's going to be like this. Up in the corner. There, that looks better. Okay, now I'm just going to have a sneak look at my layout here in Fusion. All right. So now we're going to pull these a bit back here. Like this. And now we are going to make an arc. And then we need to stand in the board outline layer. Our arc center is actually what we need. There, and this, it's going, I think it's going to stop there. Let's see. Let's hide the multi-layer there. Yep, that's right. Center arc from 12 o'clock to 3 o'clock. There. Oops, did I right click? Oops. First, it's going to start in the center, then at 12 o'clock, and then you drag it down to 6 o'clock. Yep, that's perfect. now we'll just snap this outline over here, because this is actually where it's going to be connected. Okay, a new center arc. Oh yeah, I did that wrong. So it goes the opposite direction of the normal clock. So like this. There. And like that. Center arc. And from the bottom and up to the top. There. Now, what we're going to do is that we'll take this end and connect it to that end. And this one is going to be connected to... Oops, I think we dragged it. Okay. Yeah, I want this end, and it's going to be... The right side is going to be attached to the bottom of the circle. It's pretty practical to use these grids and the snapping tool. You can create all kinds of weird shapes and do pretty awesome stuff with it. Okay. Top line is the only line that's left. And now we have connected it to both sides. However, we are not completely done. We are actually going to create another arc, center arc. I'm pretty sure that's going to go here. And in order to make that one, we actually need to go down to the 2.5 snap. So we are going to create an arc with half of the radius. Like that. It doesn't matter if we messed up that one. Okay, let's just see if I'm doing the right thing and compare it to the Fusion design. Yeah, I think this is the right thing. We'll see. Now let me just rotate this, and this is going to be pulled all the way up there. And in order to attach this, I need to also change the snap settings again. Let's change it to 1 and see if we get lucky. All right. Not yet. Now we need to drag this arc a bit, actually, to change it. Now I actually need to go down on the snap again. In order to make this look half decent. And 0.1 millimeter was not enough. 0.01 hopefully will be enough. And there we almost have it. Might need to increase one of them to connect them a bit better. And there. Or something like that. Oops, I actually moved the entire... There. Okay. Or maybe it looks a bit weird now. I think I can pull this back. to see if, they should meet up where they make a better arc. So where there are perpendicular to each other or parallel. Let's see. Okay, there. Now I need to move it downwards. Yep, this is better. And there. Yep, that looks pretty good. And now we'll drag this line, and it's going to snap to this edge. Maybe, maybe not. Now, let's just grab this. And we can rotate it in the direction we need. So we also not only need to rotate it, we actually need to flip it. Okay, let's find flip vertical. I think that's gonna do it. Yep, that helped. Let's zoom in on this outline here. And there we go. Okay, it's decent. Yep, decent for sure. And then it snapped also back where it's supposed to be. Okay, let's delete these now. We didn't need them. So let's grab both of these now. We can actually even delete this line here. And we'll select this outline and this curve. And this one. And we can copy it. And we can flip it. Flip vertical. Yeah, that didn't work. Flip horizontal, I guess it is. So let's flip it vertical back and then flip it horizontal. There. Now let's see if we can attach this to this here. And we can check the location of this. So this is at y minus 17. Huh. Let's make it minus 18 and 18. And we can make this. Yeah, it's actually almost the same. You would never notice that actually. And this one needs to go up just a tiny bit. Do something like that. And just one more tick up, I think. And there we have it, almost. There. There. Okay. Let's put it back multilayer. And we are going to add some placeholders for the FPC connectors. We'll be adding that to the document. Now, let's put back on snap size 1 so we can make an easy circle. So we're just going to do like this. And then we know that at this point, minus 18, 30, we will leave out from the design because we need room for the FPC connectors. Okay, let's save this. If I want to add the same design as I have in the corner here, I mean in EASYEDA, let's see if we can bring that up. There. Then we need to create a separate outline for that. So we're not going to do that right now. Or should we? Yeah, let's do that. The reason why I want to do that is so I want to place any components where that is. Let's give it a try to see if we can make it pretty quickly. Okay. So now we'll go to the outline. The reason why I'm drawing another outline is that if I'm drawing stuff on the same layer, it's going to snap and kind of half intelligently snap to the other stuff on the same layer. So this circle or line, let's remove the multilayer again so we can actually see it. And we'll also remove the top solder mask and the bottom one there. There, and I think it was the width 1 millimeter. And as we see here now, it stretches all the way to the outline. So we actually need to make the diameter or the radius a bit smaller to compensate for that. And it's 0.5, so we should 4.95. Actually, no, 4.5. There. Then that is completely on the inside. And then we can just copy this to the other locations. Now, how should we do these? Well, these sides, we'll take one of the sides, we will copy it. And then I'm just going to copy it like this and change the width of this trace to 1 millimeter. And now let's just drag it on top to see if it's going to look half decent. Well, need to change the snap settings again. Okay, let's move it to the side so we can easily see it. Oh, perfect. That pops up with some old cards. Holy fucking shit. What happened? Oh, sorry. Yeah, I thought I was in the wrong design, but it was just me. 0.1 millimeter, so we can really move it at a fine rate. So as you see here, there are some issues. You can't just... You also need to change this. One thing we could do is just take this piece here. I couldn't move it. Yeah, I know what I need to do. So what we need to do in order to make it look nicer, first of all, is to need to have the same center point, I believe. And the center is minus 27.5 x and minus 1793. Okay, that looked weird. Minus 930, 2635. Okay. Yeah, that's a mess up. Minus 27.5. There. And now, look what happens when I change the radius to 2.7. Offset. And I think that's almost good. 3.1 and yeah, it's not perfect. How come? Yeah, we can make it smaller. There. Now it's better. Okay. Now let's do this one. First, locate the set point, center Y point. We copied that. Let's copy the center X. Minus 27.5. There. And then we change the radius. And that was how much? 3.1? 3.1 radius. 3.1. There. And then we need to shorten it a bit. There. There we have it. Okay, so now let's copy this to the other side. Make a copy. And I'm going to flip it by the horizontal axis. And I'll drag it here. And then we'll see. Probably need to some adjustment. I think it snapped where it should be, right there. Okay, perfect. So now we are almost done. So the top part we can just do with a normal. If we do a snap of 0.5, I think that's probably will work. I mean, actually 5. Even 5, it's going to work, I think. See? Yeah, so because it's on the same layer, it knows that it should be like this. Because it's going to snap to the right one. There. And there. Okay. Okay, not bad. Now, let's do the other part. If we would look at this now, this would look kind of weird. This would look like an iron cross. I'm pretty sure that's not smart. So, what should we do? Let's select the outline here. Actually, not the outline, but the big fat outline that we made. And now we're going to change this to be part of the top layer. There. And it would be highly practical if we could just now click expose copper. But, oh, see, actually we had an issue here. We need to change that to the top layer. Okay, so that's not possible. So, see, we're now run into some kind of bug. Let's try to save. Doesn't work to change the type. Well, what do we do then? Let's delete this, delete that one, and then we'll just be standing in the top layer and just do the same thing. Want to merge the net? Yes, clearly. Oops. Let's dry this up. Oops, almost. Okay. Let's see if we can. Okay, we just need to redraw it. There. Okay, come on. That's where it should be. Okay, let me hit save. Now, in order to expose the copper, I need to hit one line at a time. So expose copper, like that. Let's do that. Expose copper. There. See? All right. And this expose copper. And that little part, expose copper. It almost looks like nothing happens. The reason for that is that the solder mask hides behind the copper. Now, let's hide the top layer mask and see. Okay. Let's hide the board outline, because I think that's what's happening. I'm going also to, because I want to expose the copper, but I'm not sure I'm selecting the right piece here. Okay, let's have a look in the. Okay, that looks half decent. So in the design in Fusion, I also did like a small bevel on the inside. If you look where the 3 is, up here. Now, let's see if we can recreate that in a way. Okay. So this is actually a really small bevel here. Let's do an arc, and let's add some really small snap size. So this is 1, 2, 3, 4, 5. Okay, let's rotate this and see if this is what we're looking for. Looks promising. However, we need a bit less snap to move this in place. Where it should be. There. Actually. Okay. It's not completely right, but is it right enough? That's better. Yep, not bad, not bad. Now let's add this to the opposite side. Or we'll add it down here first. Now let's flip it horizontal so we can have it rotate the way we want, like this. And let's zoom in. There. Now let's do both at the same time on the other side. This might be a little bit too little, actually. Well, we'll see. We can also change that later. I guess there won't be much else that close to this track. Not that easy to actually select it. I'm not gonna. There it is. Copy, paste, and flip it. Flip horizontal. Now we only need to care about moving one of them at a time because they are both selected. Or at least they should be. Yeah, that looks half decent. And same here. Okay, hit Control S. So let's select all of the tracks and then we'll add a new net called what should we call it? Called Fluff, because that's what it is. Okay. If we want to do this on the bottom layer, so we can just copy everything. So I'm not going to do that now. Okay, someone is spamming the Twitch chat. At least I get spammers. Let's see what I can do with this. I'm gonna delete Whisper. What the fuck? Timeout. Ban. Okay, one banned, one to go, and banned. There. It's gone forever. Okay, back to the circuit board. So it might be done now. Yeah. Should I also make the bevel here, maybe? Yes, I should. The reason is that you don't want to have like some super small details like this if you don't need to, because it's going to be acid bathed. And you don't want to leave like these kind of corners if you absolutely don't need to. So let's just save this. It actually got stored as a module beneath another project. Yeah, I should learn more about how these modules work. However, now that we have made the outline, we have also added the placeholders or lines for the FPC connectors. We can go and look at some of the components that we selected yesterday. Okay, so let's change out the sense resistors. These are just too big. So I don't have any problems soldering 805. I can also solder 06. 03 parts. However, that's a bit tedious because those are so lightweight that if you just touch the paste with the soldering iron, it can move it quite easily. So let's go back to the design here, and we'll try to find some new sense resistors. Let's go back to LCSC and have a look. Resistors. Low resistors and current sense resistors. Oh, I selected through hole. That's wrong. Surface mount. 0.15. There. And here are some 805. 0805. Okay, let's do all these. So let's see if we can find 1210, 1206. So the difference between 12.6 and 1210 is that the 1210 is a bit thicker, which is kind of nice. So they have these in stock. Spear Electric costs $0.2. The Uni Royale costs 0.005. That's a really big difference. So the 1210 is not the most used format, so I guess that's one of the reasons why they are a bit more expensive. Maybe everyone have the same format as well. If we remove the 805 there, no, they don't. Okay, so let's just go for the 1206 ones. Yep. We'll go back to our design. Oh yeah, there is EDA. Hit library, search for this new part. Oh, you need to go to LCLC Electronics as a source, and then we'll place it here. 1, 2. We don't care that much if we mess up the component count, because there might be more changes, and that would be kind of a waste of time. Okay, so as I said the last time, do the change in the schematics, and then go to Design, Update PCB. I'll need to check the nuts. Apply changes. There. And we'll see that, yeah, these are a lot smaller. So let's check the pinouts here. So this is OB1 and OB2, but where are the OA1 and OA2? Well, they are on the opposite side. Well, I guess that means that we should really reorient this chip. And let's flip it around 180 degrees. So now we have the signaling at the back. Should we do that? Yeah. Yes, we will do that. And that will make us able to put the sense resistors all the way up back here. And because these resistors are so big, we can actually route the VCC IO straight through this. We'll do that a bit later. So let's try not to have it too close. So I think we'll just work with these for now. Oops. So there are some components which are more important to have really close by. In order to figure that out, we can actually head over to the datasheet. Obviously, we can just look at the design that they're made. And here you can see that, okay, so like this C2 capacitor, it's really close because this is for decoupling. And these actually are oriented in 45 degrees, which is not that normal. I guess that is also to make them as short or as small as possible. So let's head over to the datasheet and we will look for so here, sense resistor. So for BRB, sense resistor connection for coil B. Place sense resistor to ground near pin. An additional 100 nanofarad capacitor to ground. Let's search for near in this document. So power ground, connect ground plane near pin. Yeah, I guess so. Sense resistor and VS motor supply voltage provide filter capacity near pin with short loop to the nearest ground and pin. Okay. 5-volt output. Larger attached at 2.2 microfarad or larger ceramic capacitor close to ground near pin for the best performance. Okay. And this is the BRA for the other coil. It's the same. Use low ESR capacitors for filtering the power supply. The capacitors need to cope with the current ripple caused by the chopper operation. A minimum capacity of 100 microfarad near the driver is recommended for best performance. And we obviously don't have that much, but we have in total because we're going to stack multiple drivers on the same board. And they will all be sharing the same input power track. So we'll just loosely place these. So these are supposed to be close. However, we can also see here that the outputs here. Yeah, something that I forgot to mention in the last stream is that if you look at this, there's so many NC. Why do they do that? Okay, now let's have a look at the design. I think there's the image of the layers here from the evaluation kit. I'll explain why. Okay. It's pretty big. Okay, let's search for eval then. Okay. Maybe we can't see it here, but we'll try. Okay, so here you notice that these are kind of larger inputs because these are where the motors are attached. And the reason why they are NC is that you can actually attach them to several of the pads. So inside the chip, they are connected. Or they might even not need to be connected, but they are at least connected to the package. This will help distribute heat better and also have a larger contact point for the high current. So let's figure out, if you look at the component here, I think we can double click the footprint. Yeah, see? And here it's like this map of everything. And if we go to the component bin and go to, for example, OB1, here you see it goes, and it has an NC on both sides. And here, guess why? Well, we are going to attach them on or both of the sides. That also means that we need to attach netlist to them. So they need to share the same net, or else we'll get an error at the end. However, for now, let's just wait. So we're going to place these. Actually, I think we're going to place them here. Maybe. Oh, no, not really. No, we'll just have them up here for now. I need to figure out how many I can actually fit. Just like to remove the names of these components because they can just come back quite easily. Okay, now let's find the decoupling capacitors. So this 22NF can be really close. Let's just put it here for now. And let's bring out the sidebar here, and then we can get the component list. So 100 nanofarad, let's bring out all the 100 ones. Because these, the smaller the capacitor, the closer. And the reason why you see that they are like dual pairs is because you can have them close to the pins that are actually going to use them. So there's not many components on this design, which is quite nice. So this is the VS input. So we will put these down here. Let's change the snap to 0.5. I like to have as large as possible snap at the beginning, and I'll change it back later because it makes it easier to make like a nice design. You see here, Trinamic made this into an easy job because they have multiple inputs from both sides. And this is something I really like with these drivers, is that the chip designer has actually spent some time on trying to have the different outputs in a nice location. Many other, I'm not sure if it's like the manufacturer or the product, but many other products have really bad way of placing the output pins on their chips. Let's just have a really quick check to see. Yep, no YouTube comments. That's fine. We're just getting started. NC7, that's the, yep, that's the large one. So VCC IO will be here. So let's just move everything a bit up like this. And we'll add these here. And we also see that we are probably going to add some bias here, for example, for the RVENN. It is actually possible to have like a trace on the inside here, which is quite nice. And now we have the LED. I'm not sure where I should place that actually. Should I place it close to this so you can kind of see it through the hole, or should I place it somewhere else? Okay, let's see after we have added more of these drives here. Okay, now it's for the so ideally, we should have some of these capacitors as close to this chip here as possible, as close to VS. So how can we do that? But at the same time, have enough space for these. First of all, let's go and change the schematics for these NCs. Let's just bring out the footprint. NC, so 16 and 18. No, it's 16. We'll do 16. Oh, these are for the sense. So, yeah, 14 and 16. Yep. We'll just use one. 14 is OB1 as well. OB1. Kenobi. OB1 there and add that there. Yeah. And it was 14. Oh my God. How hard can it be? Oh yeah, it was that. And then we have 16 is close to here, which is not used. Okay. What does that pin do? $16. Okay. Let's see if we can add it to this one here. Then we have OB2. That's 18 and 20. Yeah, I think you see this pattern. Yes. And this is for the VS. 22. Oops. I need to call that OB2 and not OB1. OB2, and then we'll add this one as VS. I just need to double check this later, so I accidentally don't put something where it really shouldn't be, because then it would be really hard to fix this if we get the circuit board with this kind of error. So pin 31 and 36, I guess that is on the opposite side. 41. Okay, so 47, 45. No, I think OA1. OA1. And then we have OA2, which is 41 and 43. There. Now, 31 and 36, I guess that is for the VS. 41, 39, 41. Okay, 40, 41. 40, 39, 38. 31 and 36. Oh, that's over here. 36 is nothing. The other one. 31. I bet that's the other corner. Nope, it wasn't. Okay, so it looks like this could be used as a super ground pin. However, do I have a double VS? Yeah, I have that here. So both of them are. So I don't need to have a double track there because they are there already. So 22 and 20, are any of these NC pins? Yeah, I haven't updated it. Okay, so let's update the design. No, keep going. Now you see this makes more sense. Now let's look at the data sheet for the different pins to see if it's described here. $14. Do not connect these pins provided to increase creeping distance on PCB in order to allow higher supply voltage without coating. Okay. But why did they do that in the design here then? The Bob. Okay, that's weird. Let's go to design and just have a look at the copper for ourselves. Maybe we're missing something. Show Altium design online. There, online PCB viewer. Let's upload this file package again. There. Okay, that didn't work. But it worked yesterday. maybe I uploaded the wrong file. Okay, this looks better. PCB. Let's bring up the layers. Let's zoom in. Let's remove the silk screen. Yeah, that was removed. Top solder. I'll just remove everything except the top copper. Yeah, you see, they're actually not attached. So we're not going to do that either. Huh. Okay. Let's change that back then. That's going to go pretty fast. 1, 2, 3, 3, 4, 5. 1, 2, 3, 4. And oops, wrong paste button. Okay, let's update the design again. Update PCB. Nope, keep going. Okay, and apply changes. There. Okay. So how can we make the design a bit slimmer? Yep, we can do it like this. If I want to add some of these capacitors a bit closer here. So remember, I also actually have to route these, right? So let's add one down here. We'll put them something like this, because we're going to use a double via to pull the coil or the motor, the stepper motor tracks. It's right outside of the package and then dive into the board on another layer. There. So I'm trying to route this at the center line, because then I can quite easily see that, okay, X location is 6. Okay, then it's symmetric. I can also move these a bit more up here, like this, and I can attach these here. Maybe, okay. This, oh, let's just grab the circuit board from here. Copy this. Okay, we need to do something first. First of all, let's put on snap to 10. No. Okay, that didn't work. 10. Now, because we're going to copy it, we're going to select the reference point in the center, because then we can copy it in the center as well. So we'll get it exactly where it should be. Now, let's just lock this so we won't accidentally move it around. This is not locked. So now you can see that, oh, that's not a lot of space. So at least there are some more here. And you see that we would benefit from having kind of slimmer design. let's just try to put a track here. So let's do snap size 0.1 for this. And oh yeah, we're not on the right layer. That is why it didn't snap right. 0.5. Okay. So we can do something like this. Yeah, it's obviously not gonna be right there because we'll have there and there. Now, what we're going to do is that we're going to take this last part. So I'm double clicking it, and then it selects the kind of the final path. And I'm going to change the width. Let's change it to just 1. Oops, I changed everything. So you see, that's like, okay, that's going to stretch over quite some area, but that's fine. So what we're going to do, make these. And because we have a snap that's so high now, it's not going to hit the right places. Okay, let's save and refresh. There. Let's see how big. Yeah. So you see the on the bob, it goes straight into a ground plane here. So this one is oriented in the other direction compared to what we're doing. Can we rotate this if we click R? Nope, we can't. VS. VS. Let's see. Yeah, it's angled 90 degrees. So you see, they kind of do the same. So it goes out to a couple of VS here and just dives down. So we'll do the same thing here. And then we can use the VS like this. Okay. Just leave that for now. And let's see. Actually, I'm going to change the snap size to 0.1 and see if I can drag these. Oops, not good. So I accidentally just pulled on this chip, and when I hit Control Z again, and we just get a ton of errors. But if I save, you're gone. Not sure why this is like this, but I guess we'll never figure out. Let's lock this. Actually, not. It's not. We don't need to do that time because we might move it. There. You can copy the entire thing, actually. Okay, I'm definitely gonna lock it. Copy and put one a bit more. Yeah, because you see now, so I need to get a trace out from here. From this, what did I do now? There. Let's do 0.3. I guess that's the maximum thickness. This is to the sense resistors. And they should be as small as possible. So if we look at here, the sense resistors are they're kind of sticking out here. There is this one. Yeah, you see these are the big ones. So they kind of prioritize that to have these really close. And that seems to be more important for them than to have these capacitors really close. Well, where they are, but yeah, it's going to be fine. This is not going to be sent to space or something like that. Let's just change the name for this OB2. And for some reason, there's like a yellow. Huh, that's weird. Yeah, it's probably to show something important. I'm not sure. Yeah, see, they can't be closer than this. We could, however, also do this. If you don't want to have it close to the VS, but that's fine. We'll do, yes, okay, yes, that's a bit brave. I think we need to do this. So we can have VS out here. So the absolute best place for the sensor resistors would actually be here. However, that will make the design way too wide. So what can we do with that? We could reorient the chip. Or we could do something else. Okay, let's just try something new here. We're going to select this one. Okay, first of all, let's just move some of these out of the way. And let's do something my buddy Sian has done. The unexpected maker. He has oriented this 45 degrees. Let's just try to do that and see how it goes. Locked, no. I'm not even sure how to do that, but I know it's possible. Rotate. Let's just hit R. Yeah, it doesn't. Oh, there it is. Rotation. So we'll just hit 45. See? Just get rid of these. We don't need that now. And the VS is way up there, which is fine. VCC IO down here. And where did the... Yeah. One issue, obviously, with this is that one of the tracks will be a bit longer, or because it will be on the upside here, which not necessarily is a great thing. So what to do? What to do? Let's rotate it back to 0. So let's see if we can add one of the sensor resistors. Not here. Let's just try something here. So if you are going to fit 3, how wide can that be? Ah, I know a thing we can do. So what we can do is that we could offset the entire one, this one, further down here, right? And then we could pull this one a bit up, and then they can kind of overlap each other, at least component-wise. So let's try to do that. Let's try to add these back here. I've also oriented it 180 degrees because I wanted to have the VS closer to the top of the board there. Now let's add something of 1 millimeter, and then we'll add 2 VS in it like this. And this is going to be OA1. And we also need to change the VS, OA1, there. So these are the closest. We can have them. And then this would be here. Or, yeah, that's not going to help. Let's do this one. And we'll just call OA2 there. Now let's move this entire thing up here, where it's supposed to be there. So I need to get it a bit up because I need to be able to get this one out here. The sensor resistor. Oh, I forgot to lock the chip and I accidentally moved it. Let's pull this bit down. There. Now we should be able to pull this one. Oh yeah, not with that big wire. Okay, so yeah, this is the closest we could get with this. So now let's just copy these. All of this. Oh, we forgot to add a trace. There, and there. So And now we can both of these, and then we're going to flip them horizontally like this. And then we'll add another net name I guess it's OP2 here, and OP1. OB1. I'm not going to do the OB1 can OB joke again. There, and just let's move this with key presses. How far? Closer there. Yeah, a bit closer, like this. And now let's see the sensor resistor. That sounds like a band, Sensor Sisters. Sense resistors. So it's -7.5 and 5.9. Let's just do -6. -6 and 7.5. Now they are the same. And we'll add a wire there. And we'll just move it to the side because you don't want to have like really cramped out places like this angle here. That's not good for the acid to remove the copper, or it could potentially lead to an issue there. Okay. Now, let's see about them capacitors. We can put the main voltage straight down here, and I can align these two, right align them like this, and then do the same with another one, just like that. Let's bring out this one and this one. We'll rotate it so we can do the same thing. And just drag them. I'll just do this approximately, or actually, let's do it properly the first time. X location 695 minus 695 and minus 1.6. Okay, they're at the same thing, same location. Now we can have these top bigger, align at the top, and then we can align this one to this left one here. Align left there. Now, what about these? The 471. So this is for VCC. This should be close to VCC. Where did that go? I can, if I would, like, I can go to nets here and select VCC, and that's going to highlight all of them. Yeah, it's just these two together. Oh yeah, it was, I remember. So these all need to go up, and they were placed there because we rotated the chip. So we will, yeah, this is this resistor thing here. So you can notice the outline for these components are not the same, or the silk screen. So if you're picky, you can change these and have the same for everyone. Let's see if we can. So it uses the footprint R0603. And oh yeah, it's just because it's a capacitor. So we can also align these two to this one, the big capacitor, and align the bottom there. And this one can be aligned at the center. And then we'll align these for the center. Yeah, they're not, because one of them is just a lot bigger. So it looks better like this, I guess. We probably need to move this stuff around when we are going to add some VS for the IO. Okay, so now it looks a lot slimmer. So these are the small ones. Where should those go? Well, so let's move these a bit up, and these as well. Something like that. And then we can have these a lot closer. Let's just get them out of the way for now. If I move them up a bit, can I rotate it? Okay, no, it's not gonna work. It's not gonna fly. There. And I can left align these to this big resistor, the sense resistor. Align left, there we go. And there should be two on the other side there as well. Yeah, there. Oh, actually one of them belonged to VCCIO. Let's get the one. So there's one there, and there should be one more. Where did it go? No, there isn't. That's weird. Didn't we add like a 100? Oh yeah, it's because one should be added to the VCP. I probably just didn't see. VS. Yeah, this is the VCP. We'll fit this right there. And we can add just a tad bit more to this one, and then that will align to these. And we could center this like this. Okay, then VCCIO is obviously here. We can have that here. And the CPO 22 nanofarad. Oh yeah, that's for up here as well. So let's move these up a bit so we can have room for this one. We can do it like this, maybe. And let's rotate this. We need to have it look like spaceships attacking something, obviously. Like they're in a formation. Yeah. Think we'll get that one up there. Rotate this down here. Huh. Yeah, I guess we'll just try this for now. Let's distribute all these. Distribute horizontally, and that will be evenly placed. Okay. Yeah, they need to be moved a bit because we need some V's here to for the signals. We'll just keep it like this for now. There. However, this could be something like this. Okay. We need to center align that one, center align that one, center align this one. Not sure if this is going to work. Maybe, maybe. There's only one way to find out. And that is to do it. There. Looks kind of cramped up. That's the way. Okay. Now, save this. And these actually need to do it like this, I presume. So let's see if my idea works. Save. We'll just move this. Oops. I forgot that it was large. Nope. And let's do snap of 1. I don't need to hit that. Probably need 0.5 to have it more center aligned. Yeah, there you go. Okay. So my idea then was to, it should, yeah. So this needs to be even slimmer. So I actually need to move these here. They cannot be like this. Let's see if we can get this to work. Yeah, the snapping is a bit too much. There. There. And then let's re-angle these. That's enough. Or isn't it? Maybe. Let's try. So what I'll do now, first I'll save, and then I'll just copy this and see, can I fit another one here? Yeah. And what about those FPC connectors, Marius? Yeah, this is not going to work. Definitely not going to work. At least in this format. How much less? So I need basically... So what I basically need, if I'm actually going to fit 3, I could also do it with 2. However, it's quite useful to have 3 because many drivers have 3. So we could make the sense resistors smaller. We could also move some of this stuff. We could move, I could flip the sense resistors like this, sensor resistors, and make the tracks longer. To do something like this. Or I can, let's remove this now. Yeah, they are so close to the chip now. That's like not necessarily a great thing, because this heat could help, heat this area faster, and then suddenly could pull on the chip while it's soldering. Because I was thinking I could, I could also 45-degree angle these. That will also work, but then this needs to be a bit more down there. Let's move it a bit. So essentially, if I want to have 3, I need to get all the components in almost the same line as the chip itself. Let's try this. Even though they are pretty close to the chip now. I'm going to add a longer trace on the inside here. Not necessarily the best choice. Align top. So this will make it a lot slimmer. And then, I can actually also put them even closer, like this. Was that even closer? No. Yeah, that's not. I can move these down here. Okay. Let's flip these. The capacitors are quite a lot smaller than these pads. Okay. There. Let's try to move them again. Save. Copy everything. Yeah, so this almost works. Or does it work? I need a bit more room for the capacitor for the FPC connector. I should bring that in to see how big the footprint is. But we are really close now, actually. See? Let's just add these now and see how it will look. And forget about that the FPC connector exists. However, if we would adopt the not all I/O to all boards, we could, yeah, this is going to work. I'm going to remove this pretty soon. Yeah, and this needs to be a bit more in there because they're sticking out. Yeah, maybe they should. No, they shouldn't, because if they stick out too much, you can slide on the mechanism. So let's just save for now and have a look in 3D. Okay, I guess it has some troubles with the outline. Does it even have... Yeah, I didn't get the outline at all, I think. Because I hit that. Let's select, remove everything except the outline. There, and the document. There, okay. Reference point. Yeah, I think I have a bit sensitive. Okay, that's the reference point. Zoom in. What's wrong with the... It's... Okay, there. Let's see if that helps with outline. Almost. Okay. This looks pretty stacked up. Yeah, I can obviously be using some smaller capacitors on the back there. It kind of looks cool as well. So, yeah. And it definitely looks like an alien invasion, which is the goal of all PCB designs. It needs to look like the components are information trying to invade the planet, like Earth. Okay. So I guess we are closer, and I think I'm going to take a break, and then we'll do the traces. And also, add the FBC connector and that stuff as well. But this looks kind of promising. We might need to do some big changes after we have done the routing, but I guess we'll see. I think we're going to end up 45-degree flipping the sensor sisters as well. Sensor sisters. Okay, so that's it for this stream. Look out for stream number 3 coming up next.